Have you ever wondered how far the density of an object could go? This is the Nimitz class, the biggest aircraft carrier in the world. Imagine twice the mass of this ship in a grain of sand, because this is the density of a neutron star. Their diameter can vary from 10 to 30 kilometers, but their mass is about 1.5 times that of the Sun. This leads to an average density of 4 times 10 to the power of 17 grams per centimeter cube. But let's see where such a high density does come from. The matter at its surface is composed of ordinary atomic nuclei crushed into a solid lattice with a sea of electrons flowing between them. Proceeding inward, free electrons are captured and pushed together with protons to create neutrons. This region is mainly composed of free neutrons. The nuclei become increasingly small until the core is reached, but the composition of the superdense matter in the core remains uncertain. Now, all this mass concentrated in a small radius gives rise to a magnetic field which is 2 billion times stronger than the one on Earth. In fact, if you casually dock on a neutron star, you would probably end up squashed like a dead bug, because the gravitational acceleration is 10 to the power of 14 meters per second square. Neutron stars have also a fast rotation. In order to understand where this rotation comes from, let me show you an example. Imagine a dancer spinning with his arms wide open and then closing them down to his body. He will spin faster. In the same way, the neutron star increases its angular speed from the original red supergiant. They also have incredibly strong magnetic fields, which come from the red supergiant they were originated from. So, it can be considered a massive magnet. As we know, when a magnet moves, it creates an electric field as well. In this case, the magnetic field and the rotation together create such a strong electric field that they are able to accelerate particles. As a consequence, energy is released from the two magnetic poles in the form of radio waves, optical light, X-ray and gamma rays, depending on their angular speeds. A star which emits all this kind of radiation is called Pulsar. It can be seen only if its magnetic field axis is aligned with the source of detection. You could think of a pulsar as a lighthouse. The ship can only see the harbor when the light is in its direction. So neutron stars have many rare properties, and for these they can be considered one of the most fascinating objects in our universe. But what if two of these extreme stars collide? We will see these in the next episode.